We begin our look at plate boundaries by starting with divergent margins. This is a map of the major divergent plate boundaries around the world. Note that most of them are in oceans, and for that reason we call them mid-ocean ridges. We've looked at mid-ocean ridges a couple of times already, so now we're looking at a whole map of them focusing on where they are in the world. I want you to notice a couple of things. Pay particular attention to where they meet, such as here, along the East Pacific Rise, and another one here. Note that mid-ocean ridges, or divergent plate boundaries, don't cross each other like streets. Where they meet, they always meet in something that we call a triple junction. Three divergent boundaries coming together in one location. Here's a cross-section of a divergent plate boundary, and there's a few things to pay attention to. First of all, note that these are mostly in oceans, and so of course this one is drawn in an ocean. Divergent plate boundaries are places where new crust is being created. You can see that magma in the mantle is rising to the surface at the divergent plate boundary. And divergent plate boundaries tend to form long ridges on the ocean floor. Here's another three-dimensional view, looking all the way down to the core this time. And you can see again that there is convection in the mantle that drives the separation of the two plates. Notice that the two plates are moving in the same direction that the convection currents underneath them are moving. There's a couple of other things to pay attention to in this drawing. You can see the continents on both sides. On one side, the right-hand side, is also a convergent plate boundary. So you can see the oceanic crust going down underneath the continent where it's melting and forming magma and rising to form a volcano. On the left-hand side of the diagram, however, the oceanic crust is attached to the continent without there being a plate boundary there. So that continent is just moving away. No volcanoes are forming along that continental margin. This is a more detailed map of the Mid-Atlantic Ridge. You can see Washington, D.C. and Boston and Montreal in the upper left-hand corner. That's North America. And you can, of course, see Africa and Spain and Portugal in the lower right-hand corner. So that is Africa and the European continent. And in the middle, the mid-ocean ridge system. I want you to pay attention to a couple of things. First of all, can you see a valley at the crest of the ridge? We're going to look at a picture of that in just a minute, but that's one thing that happens as the crust separates there. It rises to a high ridge, but there's a valley at the middle of the ridge. And also note that the ridge is cut by many fractures. These are transform faults, and they're perpendicular to the spreading direction, actually parallel to the spreading direction, perpendicular to the ridge crest, and they're very important, and we'll talk about them when we get to the transform fault lecture, but look how many there are in this picture. The Mid-Atlantic Ridge rises above the ocean floor in one place, and that place is Iceland. Here's a map of Iceland, and you can see the Mid-Atlantic Ridge runs right through the middle of the island. And here are some geology students. They're actually walking on the floor of the Mid-Atlantic Ridge. The rift in the middle of the ridge crest is where they are currently standing. And you can see the high rock on either side and the low valley, the ridge crest valley that the students and their professors are exploring. Now, divergent plate boundaries sometimes form on continents, and when that happens, you get, of course, magma rising underneath the continent that forces the land above it to push up and stretch, and cracks form. And as more magma is moved into place, the two halves of the continent begin to separate, and you form this nice ridge valley. And eventually, that valley drops to a low enough sea level that the sea moves in, and you are now creating oceanic crust on the bottom of an ocean. And eventually you get to the situation on the bottom where the two pieces of continent, which were once together, are now widely separated by an ocean and a mid-ocean ridge in between. Let's look at a place on the globe where a relatively new divergent plate boundary system is forming. This is Africa and the Arabian Peninsula, and you can see that there is stretching a part of the crust along three places here. The Red Sea and the Gulf of Aden are both newly formed active mid-ocean ridges, and there is spreading in both of those two regions, pulling the Arabian Peninsula away from the continent of Africa. But there's a third branch. Remember we said that ridges meet in triple junctions. The third branch is actually on the continent of Africa right now, and you can see that it is just south of the junction between the Red Sea and the Gulf of Aden. And this is called the East African Rift Zone. It's currently on land, but you can see the shape of the mid-ocean ridge beginning to form, the high ridges on either side and the low valley in between. Right now, there are places in the East African Rift Zone that are below sea level, but the edges of it are still above sea level, and so it hasn't been flooded with water yet. But it will be, and this little bit of Africa will eventually break off from the rest of Africa. Here is another rift valley on land, and this one is the Rio Grande Rift, which of course runs north and south between El Paso and Leadville, Colorado. It's not currently active, but it was an old divergent plate boundary. That's how it formed.